All right, I can't do that anymore, so I apologize. You have to listen to regular Samulus anymore. That took extraordinary concentration, you know. So hopefully I did all that math right. I think I did. Who knows? Worst teacher in the world. Blah blah blah. All right, so here we go. I gotta fast track this one and get this one over with. So secant 2 alpha equals 2. 2 over 1, by the way. All right, and this is R, and this is X. So that means Y is root 3. So again, that's what you're trying to, get. How do you know what these angles are, and what do you do? All right. So 2 alpha. Yeah, alpha is kind of a crummy variable, and my computer is not being very, very nice about the writing here. What kind of angle has a root 3 as its opposite side? And that's a 60. And we are in degrees, and it's only 0 to 360 that we're answering. So 60, and the quadrant 4, 300. Man, this pen stinks. And then 360 plus 60, because remember when 2 alpha occurs, you solve for 2 alpha, you not only have to divide by 2 to get your answers, you have to double them. So 360 plus 60 is 420. 360 plus 300 is, so what is that, 660? Again with the math. Divide by 2, all of these, and we get 30. 150. 210 last time I checked, which is less than 360, which satisfies the directions. This is why we have to do this. And then 330. Again, my pen's writing crummy, so that's the excuse for the sloppy writing. All right, and then that satisfies those directions. Next. Okay, this one's tough. Tan equals cotan. Hey, I have an idea. Just multiply both sides by tan. I'd check these answers at the end, though. It just makes me nervous. Might be like when you square both sides issue, but really it isn't. I mean, you shouldn't even be doing any math on this. Tan of what angle equals cotan of what other angle? It's all the 45s. Let's get this over with. And that's what's going to happen here when you root both sides. By the way, if you square root both sides, you put a what here? And by the way, what's the square root of 1? It's 1. For those that write the square root of 1 in the final answer, I'm going to get you. All right, that's where jerk Samulus comes out. But also it's because you're wrong. It's like writing 2 over 4 as an answer. Never. Not on my watch. All right, so there you go. Next, sine equals negative cosine. I divide by a negative cosine both sides. Wrong. I divide by a cosine. What's with this alpha? And then sine over cosine's tan of alpha. This pen's really driving me nuts. Equals negative 1 over 1. Yx. What kind of triangle has a y value of 1 and an x value of 1 and one of them being negative? It's these over here. All right, but which ones? Which ones? Where's tan negative? Quadrant 2 and quadrant 4. So those are those two answers. This isn't really that hard. They don't even have any. I only have one double angle that I've done so far. Then this last one, by golly, I hope this is factorable. Oh, for the love of whatever you believe in, it's not. 1 plus or minus a root. Negative 1 squared is 1 minus 4a c all over 2a. And then 1 plus or minus 4 times 5 is 20. Last time I checked, 20 times 2 is 40. 1 minus negative 40 is a root of 41. Now it's time to go to the calculator. And let's see. We could probably do this offline, but really we should kind of go through this. So I think I did this in class, and we can maybe go through it. We check your answers. Hopefully it doesn't take too long here. But 1 plus a root of 41. Where's the square root button for the love of whatever you believe in? I can't find it. Freaking out, man. Oh, for the love of... This is just... Oh, my God. Yeah. Root of 41. Glad this is all on YouTube. Divided by 10. And then we have to inverse tan the... Oh, no. Okay, so that's what cotan of theta equals. Oh. So that's what cotangent equals this ratio. So when I have my 84 out, so I have to 1 over this. So actually you could raise it to the negative first. What happens when I hit that? Nice! Okay, now I turned it into tan. All right, so I flipped that decimal. And now I can inverse tan. So that's how you do that. Oh boy, he's really... Okay, a second answer. Okay, boom goes the dynamite. Okay, so 50... All right, so we got 53.5. All right, that's in quadrant 1, obviously. And then where's the other angle measure supposed to be? Quadrant 3 of 53.5. It's not a formula. Oh, that means I add 180 to this. And then that's how I get my other answer. 233.4. Okay, and then this is under the directions of having to get all of the answers. So, or not all that, just the answers from 0 to 360. So, theta equals 53.5, and my memory is degrading in my old age. 233.5. All right, and then you got to go back up here and actually do all of that again with 1 minus. Oh, what a kick in the... Okay, so enter, but I don't want to enter that. I don't know if that was any easier. Hey, I had a hard time finding that root button, so maybe this is better. And then divide that by 10. All right, and then that's what cotan is equal to. So we have to 1 over this. So when you 1 over that ratio, it's now a tan. And then I second tan that answer. And you will get a negative because of that stupid restriction thing. I could put that over here. Wish that calculator stayed up when I did that. Negative 61.6. Invalid answer according to the directions. They clearly state the answers must be between 0 and 360. This isn't. So that's a reference angle. I'm going to stow that in X because I need the quadrant 2 answer, which is 180. I have to do plus because it's stored as a negative. There's the quadrant 2, 118.4. Let's see if my memory can hold these together. And then 360 plus, because I stored a negative, 298. 118, 298. 118, 298. Point. I forgot. Oh, my brain. What a day. Okay. All right, let's just keep going because this is fun. All right. Yeah. I'll verbalize 20. We did it in 4th period. Hey, 2 sine x cosine x. That's sine 2x. If you don't know that, that's your fault. All right, and then when you inverse sine 0, no restrictions. These are the directions. Where do you get 0 as a sine value? Remember this plus minus thing could be possible. Y is 0. R is plus minus 1. What? That can't happen. Did we make a mistake? Wait, I'm freaking out, man. Inverse sine is 0. R is 1. Yeah, no, what am I doing? Oh, I'm so embarrassed. Okay, so, yeah, this could be, y is 0 in 2 places. Let's look at it that way. I don't know, doing the voices, and that's not even right either. Really, and then today, all the attacks on Twitter, oh, my brain's just fractured. All right, so 2x equals 0 degrees. That's where you get y value being 0, but also 180 degrees. But it's 2x equals, so it doubles the amount of answers by adding 360, 460, 540. Then you divide by 2. And then this is where you get all your answers. So x equals, we're leaking into 19 here, 0, 90, 180. Is this really right? Yeah, wow. 180, 280, 360, and then 540, 250. This is strange. I got to check all these here. 360, 460, yeah, 540. I love when I do this all on Twitter. Twitter? Oh my gosh. We'll never go there. YouTube, I meant. 250 is 500. 270? There we go. All right, again, fracture band. I usually pride myself in my mental math. It's a little rough today. All right, and then this next one. There's not anything going on here. This is actually factorable. There's no sine 2x's or anything like that. These are like terms, so I'm allowed to go ahead and, I think, factor. By the way, good FOILers are good factors. There's another Samulus everyone appreciates. It's a good thing he says it 34 times a day. Yeah. All right, I think it's 3 and 1. And then 3 sine x and 1 sine x minus 3 plus 1. Anyone? 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 Bueller. Sine squared, sine x, negative 3, negative 2, negative. Good. All right, so sine of x equals 3. Sine of x equals negative 1 over 1. Y R. Oh no! Like Mr. Samulus. Mrs. Samulus says, can you imagine being married to her? Oh, what a voice. I have to live with. All right, R, that's not possible. All right, so, yeah. So negative 1 is a y value at what quadrant or what angle measure? And that's only at 270. Okay? So 270 degrees. All right, just double checking. Stop the video and take a break for a second. All right, to fast track this. Sorry about that. I just went to YouTube and watched that last movie. Oh, wow. All right. Okay. So tan cubed of 3x equals tan 3x. These are the same angle measures. So what I'm allowed to do is subtract. You can't divide. I talked about this 4th hour. Do you divide by x when you have x squared equals x? No, because 0 is one of the answers. We can see that, right? If you divide by x, then you just get x equals 1. You think you're all proud of yourself. When you're actually supposed to subtract the x and then factor. So that's what you got to do on this, and then I'm just going to kind of show the rest of this math, and it really should make sense. Okay, minus tan 3x, and now just treat this like a variable. You know, this is x cubed minus x. You can pull out an x, so you can pull out a tan 3x, and then you're left with tan squared minus 1, which is tan minus 1, tan plus 1. So you factor that in those 3 parts, and then you do the zero product property 3 times. Oh yeah, you do have a situation where you have this many answers. And I have them all listed here. So this is what we did first. I'll try to highlight before the 3, dividing by 3. Now, where do you get tan of inverse tan equals 0? And that actually happens at 0 and pi. All right, but then you have to triple the amount of your answers by adding 2 pi, twice. Then you divide all of these answers by 3 because that's what 3x is equal to. And then lo and behold, all these answers are between 0 and 2 pi. So just from this one, you get these 6 answers. Hi, caramba. And then where do you get a y value and an x value of 1? At the 45s. Pi over 4 and then 5 pi over 4. But then you have to triple the amount of answers by adding 2 pi. Now I'm getting sick of people not being able to do this. 8 pi plus pi over 4 is 9 pi over 4. Get over it and do it. 9 pi plus another 8 pi over 4 is 17 pi over 4. 5 pi plus, I'm not doing that anymore. All right? And then you got to multiply them all by 1/3. And there is some canceling that would get you. Do have to do reducing. I'm not teaching that anymore. I'm not here for that. That's something you should have learned in grade school and then gotten good with it. Just do it. Just do it. I know you get mad when I say it. I don't care. All right? Cross cancel. This doesn't cross cancel. And then tan 3x, where do you get a negative 1 over 1? That's the other 245. So basically it's all 445s. But then you got to triple the amount of those answers. Ay caramba. 1, 2, 3, 4, 5, 6, 12, 18 answers. It's fine. It's okay. Don't get mad. Okay, and then how do I solve for x on this? Well, we got a little y in here. So what I got to do is free that x. So first thing you got to do is divide by 2. I'm not doing all these. Some of these are pretty simple. And then you inverse sine. So I divide by 2, then I inverse sine. I'm doing that right now. And then you get 2x minus 1 left over. So then what you do is add 1, and then I'd multiply by 1/2. So actually your final answer would look like this. Add 1, I'd allow this. It's allowed. Y over 2 minus 1. I guess you should kind of have that in parentheses. Not really, but kind of. Whatever. Who knows? All right, and then multiply both sides by a half. I guess you could distribute it, put a half in front of the sign, and then make this minus a half. Whatever. All right, this one's about the same. This one is really about the same. Multiply by 3/4. Not really. And then you get 3 pi over 4, right? And then you tan that. So you end up with, because arctan, tan both sides. I shouldn't have to cover that. Thought that was a pretty simple lesson. What is the tan of 3 pi over 4? Last time I checked, I think that's -1. Because this is a 45 in quadrant 2. And then I multiply both sides by 2. So x equals -2. You can always check these answers. What's -2 over 2? 1. All right. -1. My bad, dogs. Ooh. Wait a minute. I just saw a conundrum here. Yeah, I stopped the video because my mind just got blown, and I know you're like all frustrated. Some people are, struggling a bit and don't want to hear these things from me. But x equals -2. Because of those stupid, dumb restrictions, when I put -2 in here, when you inverse tan -1, you're actually supposed to get negative pi over 4, the quadrant 2 answer. And unfortunately, that doesn't work. Now, I'm not going to have that happening on the test tomorrow. So in my mind, that means there's no solution that can make this work out because of those restrictions that somebody, remember, I'm just the informant, made up way back in the day. So you got to understand that. If I could put -2 over 2 in here and inverse tan -1 and put 3 pi over 4 as an answer here, then we'd be fine. But the restrictions don't allow that to happen. Again, don't worry about that tomorrow. We'll make sure that that does not happen. So don't, blow a brain gasket on that one. I am going to do this one, though. This, I don't want to give away too much, but you should be able to make some adjustments concerning what, a question might look like on the test tomorrow that's very similar to this. So you get this equal that, and then how do I solve this? Well, I need to solve for x and get that by itself, so I need to inverse cosine. Well, this is a question you've already, I keep doing that. You have to cosine both sides. So this is a question you've already did in section 6.1. Brain gasket again. Ooh, sorry. Something in there. All right, so quadrant 1, 2, 7. 7 squared is 49. 49 minus 4, is that 45? Last time I checked. Oh, and then that's 9 times 5, so it's a 3 root 5, right? Sorry for my pen. So when you arc sine, you get theta. That's theta. And now we have to cosine theta. Well, cosine theta goes back to the same triangle. It's like we're going in circles here. And then you get 3 root 5 over 7. Right, so that's what 24 is, very simple. Then 25 is not as hard as it looks. Basically, you inverse sine root 3 over 2, quadrant 1 answer, it's a 60. So it is that pi over 3? All right. And then multiply that by 2, so you get 2 pi over 3, and then subtract it. So when you subtract 2 pi over 3 from both sides, sorry for this math floating around, I'm sure you enjoy that. I don't even know what that's from. I think that's from checking our answers of number 39. And then you subtract 2 pi over 3, and then what you're left with is arc cosine of negative pi over 3. Then you inverse cosine that. You cosine that. Keep doing it. Sometimes I hate myself too. Oh, I don't want to say that. Sometimes I make myself angry, and I want to go to Twitter and pop off some insults, but I'd be unprofessional. Cosine of negative pi over 3. That's in quadrant 4. That's a 60. So that is a half. Yeah. Okay. All right. Now we did this one in class, and I'll post this video and I'll tell everyone on the calendar. At least look at the end of this video. Of course, that means nothing to you right now if you're not listening to the video. Whatever. I don't know who I'm talking to right now. So here's number 39 from the old HW yesterday. Subtract our cosine and then sine both sides to get 2x by itself. And this is what you end up with right here. Okay, now, when you arc cosine x over 1, by the way, you get theta. So this is sine difference sine rule for theta, for, you know what I'm talking about. So it's sine cosine, same sign, sine cosine. All right, and that's what we do. Now, how do we find the cosine theta and sine theta? We make up that triangle like I did in the notes. Don't make this a big deal. Okay, and then I mentioned something about restrictions and, you got to do this and that. No, you know what? Just check your answers at the end. Fourth hour, you don't need to be listening to this. We did this unless you were like staring at ceiling tiles or, looking out the window, wishing you were out in the weeds. So this is x over r. All right, different x than this, what I'm saying. So this is adjacent over r, and then how do you find the y value? It's just 1 squared minus x squared, square root that. That's the Pythagorean theorem. That should not be a problem. This is what I was talking about. Wait, where is this triangle located? There's these restrictions that are ruining my life. All right, don't worry about it. Go ahead and plug in sine of pi over 6, which is a half. Cosine of theta comes from the triangle x over 1. Sine of theta comes from this triangle, unfortunately. I read 1 minus x squared over 1. And then cosine of pi over 6 is I read 3 over 2. Then you got to solve this. And actually, this is an algebra 2 equation. Regular. I asked my regular students how to do this. So we got to be able to handle this. What I did is multiply by 2 first to get rid of the 2's. Okay, so we're on this step right here. Then I subtracted x. And then I squared both sides for freedom. Boy, I wanted to be Braveheart today. What I really wanted to be. I wanted to be Braveheart with my face painted. I switched that around. And then running down the hall with my, ruler sword. And then having the guy that was playing the guitar with the fire flying out of it in Mad Max next to me with the, banging the bongos. Oh, man, I was so fired up. Anyway. I digress. All right, so 3x squared is 9x squared, and then square freedom, that's how I went on that little tangent there, and then distribute the 3. Tangent, I don't see tangent anywhere. And then minus 3x squared, add 3x squared, that gets you 12x squared equals 3, and then divide by 12, which is 1/4, and then arit both sides, and you get plus minus a half. Now, you should be able to handle that math and solving. Now is the conundrum of which one actually works. And when you put in a half, I showed this with the other ones. Arc sine of half times 2 is 1. Let's leave these as positive. And then arc cosine of a half. The problem with this is arc sine of 1. Let's get this right now. Y and r is, I'm struggling, pi over 2, like I said, long day. Oh. And then our cosine of 1/2, that's a 60 in quadrant 1. Pi over 2 plus pi over 3 does not equal pi over 6. So there are restrictions imbued in this question. Big word, Mr. S. Don't worry about it. Get both plus minus, check which one works. All right, and that's what might happen. Or maybe not. I don't know. Who knows how hard we're going to get with this test here. This isn't really that bad. I know it can be a little confusing, but it's not the worst thing. So let's put in a negative 1/2. All right, so negative half times 2 is negative 1. Negative half goes in for x here. Inverse sine of negative 1 over 1, according to restrictions, is negative pi over 2. So that's what this becomes. Plus, and then inverse cosine of negative 1/2 per restrictions, we have to go to quadrant 2, and that is the 60 in quadrant 2, which is 2 pi over 3. Now to get a common denominator, sorry for the mess of the math here, but I'm here too long. It's already 3:40. This is negative 3 pi plus 4 pi, which is pi, over 6. All right, so for this question, number 39, x equals a negative 1/2. So just check those answers instead of worrying about restrictions. Which one is it, plus minus? Oh, and by the way, when you square both sides to solve a question, you get plus minus. Don't forget that. Okay, and then I had one more. I got to stop the video. I got to show you something. No, I don't. Yes, I do. What is happening? Okay, and I noticed there was nothing in the review that was like this, and I will make a note on the calendar that all should look at this last example. And then tweet your friends, or whatever the heck you do to, send information. Put it on my face or Facebook. My face, that can't be right. All right, so remember this last example? 2 sine theta equals 1 minus 2 cosine theta. And the problem with this, and we did this is our last example in the notes for 6.2, I believe. There is no in this one fancy dividing by sine or dividing by cosine because this one's screwing all that up. So, oh, you're like freaking out. What do? I hate Mr. Samuels. Oh. Okay, well, what you could do is square both sides because there is a bridge for sine squared and cosine squared to turn into one or the other. So when I square both sides on this one, I could turn the sine squared now into 1 minus cosine squared. Mayday, mayday, mayday. I did this during the notes. Hey, does negative 2 equal 2? No. Does negative 2 squared equal 2 squared? Yes. So you may get a false positive out of this. You may get extraneous solutions because of this basic idea here. So after you solve something like this with the calculator, check these answers. All right? And that's a must in this, and I showed you how to do that in the calculator, so on and so forth. All right? Good luck tomorrow. I do want you to do well. Sorry for being a jerk today if I made anyone mad.